So here we were doing the learning objectives. So by the end of this lecture, you all will be able to understand that what recursion is, explain the base case and recursive case. Okay, trace recursive function calls that we call the function recursion, right? So we'll be able to trace those calls and compare recursion with loops. Okay, loops and recursion are like doing kind of same thing, but they both are like used in different scenarios and different situations. So, and solve mathematical problems using recursion. Apply recursion to simple real world problems. Okay, so moving on to the theory part, there was introduction to recursion. And what is recursion basically? Recursion is a programming technique in which a function calls itself to solve a problem. A function calling itself for solving a problem is known as recursion. So, okay, instead of using loops, a recursive function repeatedly calls itself with a smaller version of the problem until a stopping condition is reached. So instead of using loops, when we're using a recursive function again and again repeatedly, so it what it does is it makes the smaller versions of the original problems, means it breaks down the bigger problem into smaller ones. And we need to specify a condition that when it is reached, the recursion loop that it is running again and again, that thing will stop. At a point, it needs to stop, otherwise, it will show an error. So, basic condition that you have to specify for it to stop, that is known as base case. So, definition is recursion is the process of solving a problem by breaking it into smaller instances of the same problem. Alright. So example are, imagine that you are standing between two mirrors. Each mirror reflects the other repeatedly. So you see that whenever you are standing between two mirrors, when you see in one mirror, you'll see other mirror on the other side also, and then you see that there are lots of mirror inside a mirror and mirror, like they are going to infinity, like that. Okay, so similarly, function a will call function, then like you have given a function that is function a, then you call function a, then you again call function a, call function a, and then you specify the condition that when like maybe the answer you get. Okay, at a point you got your answer, you got everything, now you want the condition to stop. Okay, like the process to stop, otherwise it will go to infinity and it is never going to stop. So you have to specify a condition where everything has to stop. And here the slide 2 is like, why do we use recursion? Why do we need to use, like what are the uses of recursion? Recursion will help in solving the problems that are naturally break into smaller subproblems by uh, breaking the big problem into smaller subproblems is how recursion works. So this is how it is working, like making sub problems or numerical problems. So examples will include factorial, Fibonacci series, and binary search, traversal, folder, file navigation, maze solving, toggle of node. So what are the advantages? What will be the advantages of using recursion in your functions? So advantages will be cleaner code. Code will be cleaner and like you, it will be readable and efficient enough for you to understand. Cleaner code will be there, easier to understand for recursive problems. For recursive problems, it will be really easy in understanding the code that you have written instead of writing everything in loops. Okay, useful for tree and graph structures. It makes it really easy whenever you have a situation where you have to make a graph structure or a tree structure over there. This recursion will be really useful. Reduces more complex code. Complex, your code will be less complex. So that is how it has advantage. And what are disadvantages? Uses more memory. Function calls stop. Like you are calling again and again, so it is using more memory. These are the disadvantages. And they can be slower than loops because here you're calling it again and again and like breaking the problem and then again doing that thing just takes a little more time, but loops work faster than this. May cause recursion error if no stopping condition exists. Maybe you did some mistake in putting the base case, like the stopping condition, that is base case. Maybe you did a mistake in specifying the base case, then also it is going to show an error. So we need to, maybe you forgot or you put the wrong base case, so that can also be a problem over there. So here components of a recursive function. What are the components? What does a recursive function consists of? First thing, two things are essential parts like base case and recursive case. Base case is when the recursion has to stop, like the condition. Without it, the function will call itself forever. It will be running till infinity. We need to specify a point where it has to stop itself. Okay, example is given. Return one like this. Okay, recursive case is the part of the what do we say code that we have written, the part of the code that is calling itself into with a smaller problem. That part is recursive case. All right, so it's like it's for flow of recursion. What is the flow of recursion? Like first you wrote factorial of 4, you've executed factorial of 4. Okay, then it worked, then it break down like this, then it broke down like this, then it broke down like this, then like this, and then turn back. Then 2, 6, 24. Like this is how it is calling, it is first breaking everything, then it is returning back. This is how we are going to get. First it is breaking down, then it is going back up, then it is giving you the answer. This is how recursion is working. Recursion first moves down until the base case is reached and then returns back up with the computed values. See, here you have to calculate factorial of 4. So it broke down again, broke down again, and then again, and then you wrote that when it is reached to 1, return back. So now it is returning back up with the values that have been computed in this thing. Okay, and then it is giving you the answer. This is how recursion basically works. Syntax of a recursive function. What is the syntax of writing a recursive function? First is def function name, then you write the parameter. You know what is parameter, right? We did that. Okay, so here first you wrote def, then function name, then parameter. Okay, then you wrote the statement, then you wrote return value. Then it is going to return the value. Then you specify another condition over here that if that thing is not met, then return this. Okay, here you are calling it function name, this and whatever the smaller problem is. There are some important rules that you need to keep in mind while working with recursion. That is, every recursive function must have a base case. Base case is really important in your recursion. Each recursive call should move closer to the base case. You should have this thing in mind that each time you are calling the function, so it is getting near to the base case, not away from the base case. Only then, if it is going to near to the base case, only then it is at one point going to meet the base case. That is how it will stop working at some point. You don't want it to work forever, right? Okay. Otherwise, recursion never stops. Oh, and a recursion versus loops is here. In recursion, function call itself. Loop repeats using for or while. Using for or while it is going to again and again repeat. While in recursion it calls itself and uses call stack. Call stack is used like stacking, bundling, unbundling, that thing. That is what it does. And it a loop will use iterations. Okay, and recursion is easier for recursive problems, and the loop is easier for repetitive problems, or problems that are going to repeat again and again. For that loop, and for the recursive ones, that is going to call that. For that is recursion is better, and the recursion will consume more memory as it is again first calling and then again going back up with output that thing, so it is going to consume more memory, while loop is generally more memory efficient. Loop consumes less memory, so it is memory efficient. So here call stack, whenever a function is called, Python stores it in the call stack. All these things, the factorial 3, factorial 2, 1, these things are stored in call stack. And then 1 is their base case. It reaches the base case. So it is again going back. So it means that it is keeping like removing the stack one by one. The most recent function call is completed first, last, and first out. So the last function that was there, the recent one, that one is completed first. Like the top one will be removed first, right? So the last one, like you started piling plates from down, right? Down one was first. Let's suppose we have 10. Okay, down one was first, then above 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 one is the top one. Okay, you reach the base case now, and you want to remove everything now. So first, but which one will you remove? You can't remove the first one from the bottom first, right? You will remove the first, the top one. That is the last one that you have put there. So that this is what it is saying. Last one for in and first one out. It works like that. Uncommon problems solved using recursions are factorial, Fibonacci series, sum of natural numbers, reversing strings, palindrome checking, binary search, tree traversal, and directory search. Common mistakes are missing base case, obviously. This leads to recursion error, maximum recursion depth exceeded. Recursion calls that does not reduce the problem size. Sometimes that you are calling the recursion again and again. What is recursion supposed to do? It is supposed to make the problem smaller with each call. And if it is not doing that, it means the base case that you have specified is not right. Summary: recursion requires a base case, a recursive call, smaller subproblems, and a stopping condition. These are the requirements of writing our recursion. Okay, so here we have a live coding thing. First program is given simple recursive countdown, like you are counting down. In this example, then what is done? First you wrote def, then you specified the name of the function, that is countdown. You want to count down till n, and you want to specify that if the countdown reaches 0, then print done and return. Okay, print n countdown in -1. Okay, so let us try this in online compiler. Countdown if n reaches 0, print done. Return. And print n countdown n-1. Okay. Countdown n-1. Want to count down from 9. Oh, I need to write happening. Oh, it is not printing right now. Let's move on to other one. Second one is factorial using recursion. How to find the factorial using the recursion thing is this, like, first you specified you wrote the name, then you specify condition that n gets equal to 0 or n equals to 1, then return 1. Return n, and if not, then return n star factorial n -1. Number, you are taking the number input here. Number is the int input, enter number, print factorial equals to factorial number. Here we have to enter the integer. We want to find the factorial of, let's suppose 6 factorial came out to be 720. Maybe I want to find 75040. Okay, this is how this one worked. Here are the sum of n natural numbers that you want to find. First, the foremost thing that you do is like writing down your def and the name of the function. Okay. After doing that, you specify the condition. Here, the condition, the base case thing, has to be when n reaches 0, then return 0, or else return n plus some numbers, this number, n minus 1, print some number. Okay. Zero. So here, like we said that the problem should get smaller. This is the place where it is getting smaller, like n minus 1. If it is not met, then it will make the problem smaller. And the next thing we need to write print some numbers. I want the number to be 5. Okay. We can take any number over here, 90. Okay. Fibonacci series is the other one. Okay. Like we have done this series thing in like using other things like in loops and all. We have done this example, but here we have to do it using our this recursion. Okay. First we have to write the name of it, then we have to specify the condition. If n goes less than or equal to 1, then we want to return n. Okay. And if not, then we want to return Fibonacci series n minus 1. This only Fibonacci that was used earlier, n minus 1. That will be added to n minus 2 Fibonacci. Take the input here for the terms, integer input. For how many terms we want to find it, for that we can write enter number of terms. Okay, that will work. And also need to specify a for thing here. For I in range terms. Print Fibonacci I comma and this may work. Number of terms I want is 8. This is the Fibonacci series made out of that. Alright. Another example is power calculation. How many examples do we have? We have 10 program examples, then I guess 7, 8 real life example. Yeah, 7 real life examples. That is it, and we are good to go. Power calculation. So we want to calculate power or something. Okay. Like exponential power. For that, first thing we write def, then we write power, and base and component. We wrote that. Okay. And we wrote that if exponent, this condition, right, when the exponential power of some number is 0, then it is equal to 1. Sorry. So we have to specify that condition over here, that if the exponent is equal to 0, then return 1. Okay, and if not, then return base multiply by power, base comma power minus 1, base comma exponent minus 1. Okay, let's just write this one and then see. First of all, we write power, then we write base and exponent. Okay, now we just give the condition if if exponent gets equal to 0, then return 1. Otherwise, return base star power, inside power base was there, and exponent, deduct 1 from exponent. See, here the thing that you need to notice is first, see you don't base in par, and you specify the condition that whenever the exponent reaches to 0, return 1. Okay, so it started doing that. Okay, and if this condition is not met, then what did it do? It printed this thing in itself, that base, it would base as it is, and then multiply the par, this par thing, and base as it is, and exponent, it deducted it by 1. Okay, by deducting by 1 again and again and again and again, then at one point it is going to reach at 0. At that time it is going to print return 1. Like this condition will be met. Okay, this is the condition where it stopped working again and again. Okay, so when it met here, then it again climbs up to where it started with the solved values. That is how it gets you the value. That is how recursion is working. So here we wrote the base value and we wrote the power. It is only going to give you one line answer like this, but that is the process how the things are working. Okay, see, 7 is the base, 2 is its power, 7 raised to power 2 is 49. Okay, reverse string. How can we reverse a string in our this recursion? You know that string is like the text values. Whatever is written in there, you want to reverse it as it was written. Okay, so first you wrote reverse, then text, then when length gets equal to 0, return. This means like nothing. Okay, like return nothing like that. Then if not, then return this thing. This is like the first number is specified plus text 0, like the index 0 thing. Print reverse Python. Want to the you want to print the reverse of Python. Reverse of text. Then if length of text gets equal to 0, then we want to return nothing. This. Otherwise, return reverse text. Then 1 plus text 0. And then you want to call it what um, word do you want to be written reversed? So in our example, we have the word Python. Let us take something else. Let us take word. Okay, let me run it. Recursion and maximum recursion depth exceeded. So here's the recursion length is exceeded somehow. Where is the problem? Oh, this bracket thing has to be closed over here. See, world is written backward. Python, let's do that also. Run it. Python is it. Okay. Counting the digits. Yeah, so you specified the condition. that if the number is greater than, oh sorry, the number is less than 10, then return 1. If not, then return 1 plus count digit whatever the number will be. Double slash means like you put double slash and then you floor division it, like round off it. That is what the double slash meant, and then you print it. Let us do this. So caps lock went on. Count digits number. If number is less than 10, return 1. If not, then return 1 plus count digit num. Double slash means floor division by 10, and then num count digit. Want to count this digit. That is how. Write anything in here and you run it. Oh, some error. 8 digits are it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it counted the digit. Let us just remove 2, 3 from this. 5 digits are left. It means I remove 3. Okay. Sum of digits. Here is example for writing the sum of digits. Here also is specified a condition. And then return 0 and another condition. Sum into number. Okay. If num return 0, and if not, then return num percentage. Then we write number or divided by. Then the final thing, print digit sum. Then we write the number. Actually over here it is going to sum these numbers. The sum of all these numbers is going to be this. Okay. Okay. Let's move to the other one, that is palindrome check. You know what is palindrome? Even like it is a thing that it is a text thing that even if you reverse it, it is going to after reversing also its spellings are going to be the same as when it was not reversed. Okay. Palindrome text. Okay, then you specify the condition that if length of text is greater than equal to 1, then return true, and if not, then if text equal text 0 not equal to not equal to text of minus 1 dot false. Okay, so this, and if not that, then return palindrome text, and inside this period 1 colon -1, then you go back and then you write word input. You take the user input here, enter a word. Print palindrome word. So let us run it. What do I want to check? Let's check for bug. True. I want to check for Malayalam. True. It is also a palindrome. Okay. Next one is recursive multiplication. So here in multiplication we took two numbers, namely A and B, and if B gets equal to 0, return 0. Okay, like whenever a number is multiplied by 0, its answer is 0 only. That's why we can write it for A also. And if not, then return A plus multiply A and just decrease B by 1. Multiply A, B, and then if B equal to 0, return 0, or no, then return A plus multiply. What do we want to multiply? A as it is, and we want to reduce B by 1. Then we want to print multiply for two specific numbers, that is 9 and 5. Spelling mistake. Okay. Now it is 45. 9 5s are 45. Okay. Now some real world examples are here. Like like the first is folder navigation, like you want to find a folder thing. Where it can be used as its application. File explorers recursively search through folders and subfolders. So here if level gets equal to 0 then return, and print opening folder then level. Then if not then open folder level -1. Open folder 4. I'll just copy paste it over there to understand how this works. Here, like the folder is given, level is given. Now we specify the condition. If that is met, then return. If not, then print opening folder level. Then this. Okay. Now opening folder 2 and 1. It is written over there. Like opening folder 4 was there. 90 if I write. Opening for C lots. For 4 it was 8. Family tree. Okay. Like these are few of the examples. I'll just do. I hope you understand the concept. That is the basic concept. I'm just going to help you understand how it is working. That's why I'm just copy pasting it over here. See generation. It is telling how many generations have been ancestors. That it is like first it is whatever thing you wrote here, but first it is doing something to reach this condition. After reaching this condition it is going back to the first thing that it was there with calculated values, and then it is giving you the first thing only. That is how recursion is working. Okay. There's like company hierarchy. We have not written anything here to print, that's why it is not printing. Company CEO, then manager, then employee, then all these brackets are closing over here. It is basically inside it is kind of nested thing because it is inside this and this one is inside this, like that. It can be used for organizational charts, can be explored recursively, and similarly this website menu is that. Then binary search concept. Instead of checking every number one by one, binary search repeatedly divides the search range into halves. Okay, search 35. So it first thing is this, then the middle, then search left or right, then repeat. Okay, comment replies. Reply for social media, reply like that. Applications like Reddit, YouTube, and Facebook store threaded replies using recursive data structure. Have you seen that thing that reels and all are there that if you want this product, right? Just no, like in some chats also, you just business chats. You just type something and then it replies on its own. It can be a type of example of that. Then tree structure, you can see here how it is trying to tell the tree structure. The traversal tree tree traversal algorithms use recursion to visit each node. So here are some practice questions that you can practice for yourself for making everything like whatever you studied final. Write a recursive function to print from 5 to 1 and others also like half of these things we have done. Okay, and but still you can try making everything final like medium level is like reverse a string using Gaussian. Count the number of digits in number recursively. Find the number of digits recursively. Check whether a string is palindrome using recursion. Print the Fibonacci series using recursion. Multiply two numbers using recursion without using star. Okay, find the product of all elements in the list using recursion. Find the maximum element in a list using recursion. So here is a little quiz for you all to understand whatever you did was like you understand or not, like is it there in your mind like that. What is recursion? Loop statement, function calling itself variable declaration. It is function calling itself b part, right? And this one, which part stops recursion? What stops recursion? Base case, right? C. And here, what error occurs if recursion never stops? Recursion error will be the C part. Yeah. And here, which data structure stores recursive function calls? It is like stored by stack, call stack, B part, right? Which of this following is commonly solved using recursion? We can solve all of these, right? D part is the answer, right? So here is a little assignment for you all that you can just try out. Okay, that will make it way better for you. You can just pause the video and take screenshot for knowing all this, like solving all these things. Okay, like 10 to 1 factorial and then sum of n natural number, this base exponent thing, Fibonacci series, reverse string, palindrome, and the sum of digit, number of digits, and all the maximum elements in a list. Okay, without using max function. How you do. So key takeaways that you are taking from this lecture are a recursive function calls itself to solve a smaller version of the problem. Okay, every recursive function must have a base case to stop recursion and recursive case that reduces the problem size. Python stores recursive calls in a call stack. Okay, is especially recursion is especially useful for problems involving trees, nested structure, divide and conquer algorithms, and mathematical computations. For simple repetitive tasks, uh, loops are often more memory efficient, while recursion provides a cleaner solution for naturally recursive problems. So this is it for the R series, our Python series. I have covered all the things, all the topics that are required for you to know the basics, the fundamentals of Python. So I have tried my best in telling you everything, but still, if you find any problem, then you can just comment and let me know. I'll try my best to help you out with it. Also, this is not a full series, like this is not whole knowledge of Python. This was just the fundamentals, the basics. So if you want to learn Python properly, you may go with like better courses like that are little more advanced. Okay, so this was it, and thank you so much for watching this video lecture series. So this was it for the series, and this is the end of our lecture series. Thank you so much for coming along all this way. Thank you.